Hello dear students, welcome once again to our That's It YouTube channel. We have finished so far 12 sessions of JEE Advanced 2023 preparation. We have solved in this process few of the PYQs and learnt the concepts thoroughly. Especially when a question is given, the right approach to the question is quintessential to crack the JEE Advanced. As I have told you that inorganic chemistry is scoring and easier part of the entire JEE paper. You know that the questions that are asked from the inorganic chemistry are mostly simple and straight. So I suggest you to focus on the concepts which are briefly covered through these lectures so far and cover up the concepts that you have to learn and also rectify the mistakes that you are repeatedly making. So by solving the PYQs during the last few days of your JEE advanced preparation, I am very sure that your rank will further improve. So you have to learn the theory by attempting the questions. That is the easiest and best way to score the maximum from inorganic chemistry. So let's start the session of the P block elements starting from 4th group till 8th group, as we have covered in our previous sessions up to 4th group, isn't it? Now let's see the question of the day, which is frequently asked. Like you can see that you have been asked to find the substances from which N2 is obtained upon heating. That means thermal decomposition of all these substances leads to what? You take ammonium nitrate. If it is nitrite, it would have produced N2. And you know about ammonium nitrate, that it is the major source of preparation for N2O, nitrous oxide. So A will not produce N2. If this would have been NO2, then it would have produced. Now A is not the correct answer. Now you can see ammonium dichromate. You study this in the basic properties of the dichromate or ammonia. You know that this upon strong heating gives rise to N2Cr2O3 and H2O. Alright, this is internal redox reaction. That means what? Inside -3 is changing, nitrogen is changing from -3 to 0 and chromium is changing from +6 to +3. So this is acting as a reducing agent, giving away its electron, and this is acting as the oxidizing agent internally, because you know the dichromate in acidic medium, since there are ammonium ions, is a strong oxidant. So this is possible, isn't it? So option B is correct. And you know that when you take barium azide, that is N3 minus, you know that it is smaller in size because of the nitrogen atom. It would have a stronger bond with the magnesium species but not with the barium species, because barium is large. So this upon heating gives rise to the barium and N2 gas. Lastly, Mg3N2, as I just said, this does not undergo any sort of thermal decomposition because Mg plus 2 N minus 3 sizes are approximately same, and this combination is stable. This is thermally stable compound. So T does not dissociate on heating. C gives rise to N2 because it is unstable, because nitrogen is small, barium is large, does not fit well in the lattice. So right answer for this question is option B and C. Alright, hope you are following. Let's see the next question. You can see that you are given the chlorate ion and reacting with chloride under acidic conditions. You know, very important reaction. You will be getting what? ClO2. This is the paramagnetic gas. Alright, here what's happening, that chlorine, whose oxidation state is +5, is changing to +4. That means this is reduction, and minus 1 to plus 4 is nothing but oxidation. So this is a redox reaction, isn't it? So ClO2 is the product which is obtained after the reaction. You can see it's a paramagnetic gas. How would I know that it is paramagnetic? You find out n by 2, which I had been repeatedly telling you. Valence electrons plus hydrogen 0, halogens attached 0, minus charge is 0. That means whenever you get a fractional value for these substances such as ClO2, NO2, etc., you have to consider this as what? The paramagnetic. So this is the easiest way to identify the paramagnetism in the covalent compounds. This is in fact a technique. Alright, so you find n by 2, and if it is a fractional value, it could be or it may be paramagnetic by nature. Now you see what's happening, that this ClO2 is reacting with ozone. You know that this is very popular reaction, gives rise to what? Cl2O6. So chlorine got further oxidized, right? You can see here chlorine is plus 1, this is plus 4. So there is no point that ozone, which is a strong oxidizing agent, would reduce this chlorine. So these two options are ruled out. However, we are left with only these two options. This could have been possible if this is a very strong oxidizing agent like dichromate. But since this is good oxidizing, decent oxidizing, but not very strong like KMnO4, K2Cr2O7, the reaction stop at the plus 6 oxidation state. Along with that, ozone gets reduced to O2, isn't it? So the gas that is obtained, okay, reacts further to give you Cl2. Okay, O6 is the right answer. That is option C is the right answer. A lot of theory is being covered through these questions. So please carefully follow these lectures, isn't it? Now you can see with respect to hypochlorite, that is OCl or ClO minus, chlorate ClO3 minus, and perchlorate ClO4 minus. You have to choose the correct statement. You have to make sure that whether you are sorting out the correct or incorrect carefully. You can see that hypochlorite ion is strongest conjugate base. Let's check the option A. You know that acidic strength order increases with the increase in the oxidation state of the central atom. So when you take acidic strength of these, HClO4 plus 7 oxidation state, HClO3 chlorine is plus 5, HClO2 plus 3, HOCl. More the oxidation state, more is the acidic strength. Therefore, the basic strength tends to become what? Opposite of the acidic strength, ClO4 minus, less than ClO3 minus, less than ClO2 minus, less than ClO minus. So hypochlorite ion, that is ClO minus, is the strongest conjugate base, is the right answer. You can see second, the molecular shape of only chlorate ion is influenced by the lone pair of electrons of chlorine. Let's see. You got chlorate ion. Alright. When I take chlorate ion, you have to find out the n by 2 of the central atom, that is chlorine. Valence electrons of n by 2 chlorine is how much? 7 plus hydrogen 0, halogen attached 0, minus of minus 1 charge. So 4 minus 3, that means there is one lone pair present on the chlorine, and you know that the hybridization is sp3. In that case, you will draw the shape like ammonia, isn't it? ClO3 minus, and there is a lone pair. So because of the presence of lone pair, this has become what? Trigonal pyramidal, isn't it? So obviously this is influenced. Now we can see in case of ClO4 minus, you will be seeing that if you take ClO4 minus, n by 2 value of the chlorine is valence electrons plus 1 by 2, that is equal to 4, hybridization is sp3, minus atoms attached are how many? 4. So there are no lone pair present at all. So you can see that this is not influenced. However, ClO minus is anyways linear in geometry because there are only 2 atoms present. So lone pair would not impact its geometry much. So only affected species is the chlorate ion is a correct answer. Now you can see hypochlorite, that is ClO minus and chlorate ion disproportionate to give as to identical set of ions. So this is a point to be considered. Okay, before that, we will see hypochlorite ion oxidizes sulfate ion. Okay, let's see that option first. That is ClO minus plus SO3 minus 2, right? We are talking about SO3 minus 2. You know that ClO chlorine, since being not very stable, you can anticipate this chlorine to change its oxidation state. Over here is +1, lower oxidation state, and this sulfite is getting oxidized to sulfate because there is a scope that ClO minus will be further oxidized to ClO3 minus, a more stable compound thermally. Therefore, this is a right answer. And hypochlorite and chlorate ions disproportionate to give rise to identical set. This we have to carefully sort out. ClO minus gives rise to, you can see chlorine is +1. If it is undergoing disproportionation, it should decrease its oxidation number, that is Cl minus plus ClO3 minus plus water, isn't it? This is only a possible way of disproportionation. However, you can see that chlorate ion also undergo disproportionation. I am writing here ClO3 minus undergo disproportionation. This might reduce to what you call ClO minus, but this should get oxidized from +5 to what? +7 or +6. So you can see that this does not give rise to the same species. You can see here you are getting ClO4 minus, whereas here you are getting ClO3 minus. So that does not give rise to the identical set of ions. So how would I know? Do I have to remember all the reactions? No, absolutely not. You can see that chlorine has to get oxidized. So you can see that it is getting oxidized to the nearest oxidation state. You can't anticipate the chlorine to go to what? +7. That's not possible under disproportionation case. That is possible only if you use a very strong oxidizing agent. But if it is undergoing self redox reaction or disproportionation reaction, then it would reach out to the nearest oxidation number. The nearest oxidation number during the oxidation of the chlorate hypochlorite ion is how much? Maximum +5, +3, etc. Okay, is that clear? So it could be even ClO2 minus also, right? This could be ClO3 minus or maximum ClO2 minus. So you won't get ClO4 minus. It doesn't give rise to, and in fact there is no point in saying that ClO what you call O3 minus is what you call further reduced and all that. You cannot expect this ClO minus to convert into ClO minus. So this is also not possible from ClO minus. So this C cannot be the right answer to the question, isn't it? Now let's see another interesting question asked. Consider the following compounds in the liquid form. You can see that it is being mentioned not in the gaseous form. So this has got no way related to the dipole moment, whereas a charged comb is brought near to the flowing stream of these liquids. How many of them are deflected? You know that this leads to what? The charge on the comb, and if this drop is getting attracted, that means only the polar species gets attracted. Polarity means net dipole is not equal to 0. Now we can see that you have got few of the species which are being mentioned. You need to draw their shapes so that you can know if there is any cancellation of the dipole. Alright, you should know how to write these shapes, isn't it? CHCl3, then you have benzene and chlorobenzene. So all these species are given. Now you can see that this O2, because of the double bond and similarity between these two, is non-polar. HF, there is clear-cut electronegativity difference. Polar, you know that this doesn't get cancelled because of the bent shape. Presence of lone pair makes it what? Bent. So dipole moment doesn't get cancelled. Over here also lone pair is making it pyramidal. So dipole moment doesn't get cancelled. There is a resultant dipole moment, isn't it? Is also polar, and this anyways out of plane. So this is polar, this is polar, this is non-polar because all the species are identical, and this is also polar. So you can see how many of the species are getting deflected. That means polar species are how many? You can see 1. Alright, polar species you need to count. So total number of species that are getting deflected is 6, that is polar. Now let's see the next question. The easy questions, isn't it? Relatively easy. Based on the compounds of 15th group, the correct statement are asked, right? So this is about the basic strength. Option A, if you see carefully, B2O5, bismuth is a metal and nitrogen is non-metal. You know that metallic oxides are basic in nature. You know, N2O5 when dissolved in water gives rise to a very strong acid, that is HNO3. Therefore, this is acidic, isn't it? So this is by nature what? Acidic, and this is basic. So option A is correct. Now check out option B. NF3 is more covalent. You see, whenever you are making the comparison, you should see the uncommon part, isn't it? You can see NF3 and BiF3. So common here is fluorine. So I'll ignore fluorine. And you know, fluorine is more electronegative, it gets minus charge, hence nitrogen gets +3 and bismuth also gets +3. So the charges are also same, but only one factor which is differing for these two is nothing but what? Size. Nitrogen size is less than that of bismuth. So in case of the cations, from the Fajan rule, right? Fajan also, more the size of cation, it is by nature what? Ionic. Therefore BiF3 is ionic, NF3 is covalent. Makes sense? Now, PS3 boils at lower temperature than NS3. Yes, absolutely, because you know, you have studied so many times that there is possible hydrogen bondings in ammonia but not in PH3. So boiling point of NS3 is greater. The NN single bond is stronger than PP single bond. This is absolutely wrong. You know that not only in this case, but in many cases like fluorine, you know that the lone pairs are not making it stabilized, right? You know, the presence of the lone pairs will make it unstable. There is a possible repulsion, isn't it? However, when the lone pairs are present with the bigger atom, you know that they will mutually get compensated by forming p pi d pi back bonding, right? So that's why when you compare the bond energies of the second element with first element with their homonuclear species, you know that second element will form a stable compound, right? So right answer will be Cl2, and here also P2 will be more stronger in bond comparison to N2. All right, so this is wrong statement. So right answer is A, B and C. Chalo, let's see the similar question. So acids HClO4 and HClO, isn't it? HClO4 is more acidic than HClO because of resonance stabilization. You know that in HClO4 there is resonance taking place between the oxygen and chlorine pi bonds, making it more stable. So there are 4 resonating structures that are possible, which I am writing over here, which is making it more stable compared to ClO minus. There is no resonance, right? Okay, only there is a back bonding, that's all, because of which it is significantly more acidic, but not comparable with HClO4. So HClO4 is more acidic because of strong resonating structure than HClO4 formed by the reaction of Cl2 and H2O. You have studied plenty of time in the properties of chlorine, that is Cl2 plus H2O, addition of Cl2 or Br2 to alkene in presence of water, you know, you have studied there also. You get hypochlorite ion but not HClO4. The central atom in both HClO4 and HClO is sp3 hybridized. We will check. You can see one is ClO3 minus, the other is ClO minus. You have to find out the n by 2 of the central atom, that is chlorine. Here valence electrons plus oxygens. You should not count, you should count hydrogen and halogens, right? Minus of minus, that is plus 1 by 2. Here also plus 1 by 2. So this value is 4, that indicate that the hybridization of both the species is equal to what? sp3. This is correct answer. You can see that the conjugate base of HClO4 is weaker base than H2O. This is also correct because this is resonance stable. So this is a weak base. This doesn't have any tendency or attraction towards the proton because it is already stabilized by virtue of the resonance, isn't it? Therefore, this is a weak base in comparison to the conjugate base of H2O. Alright. So this is a weaker base. That's a correct answer, right? So right answer for this question is A, C and D. Next, the easier one, the oxidation state is being asked, that too in JEE advanced exam. So sometimes the easy questions are also asked, but you cannot all the time anticipate. But I'm sure that from inorganic you will be getting a little bit easier questions. So that is the area where you will feel relieved. So focus as much as possible. Don't think that this is purely memory oriented, hence you are going to neglect. Don't do that, please. You can see H3PO2, all these species, you know how to find the oxidation numbers, isn't it? Now this you are preparing for advance. I can't anticipate that you don't know the methods to identify oxidation number or calculate oxidation number. I am very sure you know it, but still I will discuss once. Alright, you know how to do that. 4 into hydrogen is +1, plus 2 into phosphorus, let's assume as x, plus 6 into oxygen is -2 equal to 0. This implies x is giving rise to what? +4. So the oxidation state of phosphorus here is +4. You can see here, alright, +3, alright, this is +1 and this is +5. Therefore, the right answer is H3PO4 greater than H4, P2O6, H3PO3 and H3PO2, that is option C. Some questions are easy, isn't it? Now you see the yellow color of aqua regia is due to the presence of NOCl and Cl2. You can see that aqua regia is actually 3 moles of HCl and 1 mole of HNO3, right? Volume by volume gives rise to NOCl. So you can see that nitrogen, which is in +5 oxidation state, getting reduced, plus Cl2. So this Cl2 is actually nascent chlorine, which is combining with the gold in its redox reaction, and H2O, isn't it? So actually this chlorine is the gas which is making it appear yellow. So this A is correct and also B. The reaction of gold with aqua regia produces an anion with +3 oxidation state, isn't it? So you know that Au plus HCl plus HNO3 gives rise to what? AuCl4 minus. Here in the absence of air, now there is no air, then the product obtained is NO. Please understand here, if there is air, HNO3 changes into NO2 because this gets oxidized in presence of air to give you NO2. So don't get confused. There is absence of air, that means the reaction would stop at what? NO. And you know, in this compound the oxidation number of gold is +3. So these two options are also NO2 in the absence of air, right? So option D is incorrect because you will be getting in the absence of air nitric oxide but not nitrogen dioxide. So don't make a mistake. This is the beauty of JEE advanced questions, that the options need to be carefully read. They are giving you ample time to solve the question and giving you huge theoretical chunk to improve your rank. So you need to be attentive while sorting out the options, right? You know, please be careful while writing JEE advanced, especially when you are going through the options, right? You know, you might make a mistake in reading it as correct statement versus incorrect statement, NO versus NO2, presence of air, absence of air, etc. be careful, less than 2500 degrees Celsius, greater than 2500 degrees Celsius. So that is where you need to be attentive, isn't it? Now you can see another question which is similar. Option A, S3PO3 undergoes disproportionation makes sense. Always remember, when the oxidation number of any element is intermediate, neither lower nor higher, there is always a possibility for it to go from middle to the higher and middle to the lower. Like you have seen in the previous case also, HClO2, HClO3 is undergoing disproportionation but not HClO4 because already it is oxidized, right? S3PO3 can act as reducing agent because S3PO3 can get converted into +5, because you see in this process, you know that phosphorus, if acting as the reducing agent, that should get oxidized, and there is a possibility that this will act as the reducing agent because there is a scope for the oxidation +3 to +5. This cannot further go, no, this cannot go beyond +5, therefore this is not a reducing agent. S3PO3 is a monobasic acid, which is absolutely wrong, because you know the structure of H3PO3, that there are two replaceable hydrogens present in H3PO3. However, the third one is not ionizable because of less electronegativity difference. So two ionizable hydrogens are present. So this is not monobasic acid. The hydrogen atom in pH bond is not ionizable. So the right answer for this question, A, B and D, isn't it? You can see one more question similar to what's being asked. OS analysis, that is reaction of, already we have seen this question. Alright, you will be getting what? Cl2, O6 and O2. Alright, the oxidation state of chlorine in this oxide, you can see that 2x plus 6 into -2 equal to 0. So this is being asked, right? Very easy, isn't it, right? So this is the set of questions that we have covered in these chapters. In the coming last two sessions, that is 14th and 15th, we are going to cover the most important chapters like D and A block elements, coordination compounds, salt analysis and metallurgy. So these 4-5 chapters are very important as far as JEE advanced are concerned. So I have divided these chapters into two parts, right? Part 1 and part 2. So in every part we are going to cover approximately 10 to 15 questions, right? So stay tuned, keep watching the videos. If you are liking, do not forget to press the like button, share and subscribe. That's it for today. See you in the next video.